Isn't it remarkable how steel looks nice and shiny, and then after a couple of years in the dirt, it rusts like that? Let's look at steel just in a drop of water. So we're going to have just a water drop, air on the outside, and we're going to put a little bit of pH indicator solution into the water, so that it'll be, if it's green, it means it's neutral, 7 or 8. If it's blue, it'll be caustic or basic, pH 9 or 10. And if it's going to be acidic, it'll be orange, maybe pH 4 or 5. So remember that. So blue, if the water goes blue, it's hydroxyls, OH minuses. If it goes orange, it's H pluses, or acidic. So here's our sample of steel, a little millimeter bar at the top. We're going to put a drop of drinking water right there in the center of it, looking through a microscope. There's our drop of drinking water, about 10 millimeters across. And you notice it's green because the drinking water is neutral. And this is time equals 0. So we're now going to let forward through time. Here's at 2 minutes. We're a little bit of blue, turn a little bit of caustic, a little bit of basic there. Now notice at 11 minutes, we begin a little yellow cross there in the center. And as time progresses, 26 minutes, it's becoming bluer on the outside. We have yellow there in the center. It's becoming acidic in the center and basic on the outside rim. Notice it's starting to precipitate some rust right there where I circled it with a yellow circle. Here's at 35 minutes, it's continuing, and 41 minutes, we're continuing more yellow. The blue gets deeper blue. And so we have two zones going on here. One a yellow zone in the center where it's acidic and it's corroding, and here's at 1 hour, and blue zone on the outside where it's basic, and we're breaking down oxygen to form hydroxyls. Here's 65 minutes, and here is 77 minutes. Notice the water drop is starting to evaporate away finally after about an hour or so, and we've got the rust on the fingers. And here's 85 minutes, about an hour and a half after we started, and the rust is left in the very center, and we have this blue rim on the outside where water is being broken down to hydroxyls. So remember, we have a water drop on steel. It went to pH 4 in the center and about pH 10 the outside rim. So what's going on here? Well, to get corrosion, we need about 3 things. First thing we need is a metal, which is our steel, which we started with. Next thing we need is water, which is being broken down both by oxygen and also by the metal. And we need time. It takes time. It doesn't happen instantaneously. It occurs over a long period of time. So let's go through and look at the chemical equations. So here's our water drop on a surface of steel. The iron dissolves away, it becomes iron plus 2. Those 2 electrons have to go somewhere, so they go over to someplace else. Now what happens is the oxygen comes in, diffuses into the outside rim, and it reacts with those water and those electrons and forms our hydroxyls. Then the hydroxyls diffuse forward, and the iron ions diffuse, and we form our rust right there in the center. So there's something else going on, is acidification at the anode. Notice the iron doesn't always diffuse all the way through the water drop. Sometimes it just attacks water and breaks it down. And notice it forms rust and it forms 2H pluses. It becomes acidic. So that water, wherever the iron is dissolving, becomes acidic. So let's put our H pluses over there where the iron is dissolving. And now notice over here is that what we're having now is we have chloride in the water, diffuses over, and kind of stabilizes our H pluses. And notice our sodium pluses, they move over to the cathode, they stabilize our OH minuses. So we have an anode, which is becoming acidic, and we have a cathode, which is becoming caustic or basic. Notice is that now the anode, where dissolution is occurring, this is a dilute hydrochloric acid, and our cathode has become dilute sodium hydroxide. So these 2 reactions are going on. So we have a current loop now. We have electrons moving through the metal. We have anions and cations flowing through the electrolyte. There's a transfer of charge in order for it to have corrosion. So here's our water drop. Just a quick reminder what we did. This is blue, where the water is being broken down to hydroxyls and is caustic. The center is acidic, and there, the fingertips between the 2 zones are having our rust precipitating. So this has been corrosion of steel in a water drop. This is Professor Burley. Thank you.